everyone, Reni here. Welcome back to my channel. To those of you who do not know me, I'm a functional wellness coach and health is one of my passions. This is the reason why I opened up this YouTube channel, because it's an educational platform so all of us can learn together. Today I would like to start a series of videos on the topic of insulin resistance, and that's why I named this first video, What is Insulin Resistance Introduction. So before we continue, I really wanted to encourage everyone and to remind you that health is one of the most important assets that somebody can have. We need to cherish it and nurture it. So as we move on to the introduction of insulin resistance, a lot of the information here is gleaned from physiology and anatomy books. I'm not going to turn this into anatomy lesson, but I would like to also at the end of this short video share a book with you that I found very helpful to those of you who would like to further their education about insulin resistance. So moving on to the brief description about what is insulin, where insulin is produced, what is involved, and how exactly insulin is affecting the body. I thought it will be very helpful to just give you a quick review from anatomy perspective. So here is a picture of the human body. Here is the liver, I hope you can see it, and then next to it it's the stomach in orange. Now the stomach continues into the small intestine. The first part of the small intestine is called the duodenum. So this it's C shape in the form of C. So what we see right here actually is the pancreas. So pancreas is the organ that produces insulin. The pancreas has three parts: head, body, and tail. The head is the part that you can see here, which is in the curvature of the duodenum. And then the dotted line here, it's actually the projection, the rest of the projection of the pancreas, because it's behind the stomach. So this is the organ in the human body that produces the insulin. So it's very important to also note that the pancreas and also the liver are the two organs in the human body that have dual action or double action. What does that mean? It means that they do two functions. The one is called exocrine function. The other one is called endocrine function. Exocrine function, it's very easy to remember. For example, if a gland, like sweat gland, it's releasing its product to the surface of the skin, for example, via duct, and that's why it's called exocrine gland. So in the same manner, the pancreas, it's releasing the pancreatic juice that it's producing via duct into the duodenum. So this is the exocrine part of the pancreas. So it will be helpful to see if we imagine like a slide from the pancreas and put it under microscope. This is what someone would see. This is what the tissue would look like. So the cells that you see here in red are the exocrine cells we just mentioned. They are the one responsible for the production of the pancreatic juice enzymes. As we know, there are three major digestive enzymes. The amylase breaks down the starches, the lipase breaks down the fats, and the trypsin breaks down the proteins. So this is the exocrine function of the pancreas. And pancreas basically mostly consists of the exocrine cells, probably about 98-99%. But here is then the next function of the pancreas. These blue cells in here are cluster of cells, and they're called pancreatic islands or islands of Langerhans, and they are responsible for the endocrine function. So the difference is that in the endocrine function, the hormones are produced, and they're actually, the hormones are released in the bloodstream. So that's the difference between the two functions. So these cluster of cells, 20% of them are about alpha cells. And the alpha cells are producing the hormone called glucagon. The 60 to 75% of this cluster of cells are called beta cells. They are the one responsible for the production of the insulin. It's important also to know that the glucagon and the insulin have opposing effects, and we'll talk about it in a little bit. But then the least amount of cells in these islands of Langerhans are about 5%, and they're called delta cells, and they're producing a hormone called somatostatin, and this hormone actually affects also the production of glucagon and insulin. So as you see, these pancreatic islands of Langerhans, they are responsible for the endocrine function of the pancreas. I hope that makes sense. Now a little trivia question and answer. I remember back in Europe there was a trivia show, and they were asking one of the people in there, well, where are the islands of Langerhans located? And of course the person was not medically inclined, so they would not know that it's in the pancreas, but that's a good trivia question and answer. So the islands of Langerhans are located in the pancreas. So that's a little bit a side note here. So why is it so important for us to know about insulin and what insulin does in the body? One of the major functions of insulin is decreasing the blood glucose levels. When food is being ingested, and especially if it's a larger carbohydrate meal, then glucose is being produced in the body and it's circulating in the bloodstream. So that's where insulin comes in, because insulin, it's guiding where all this glucose to be used as an energy, it's going in the cells. That's the role of insulin. So let's just see how this process works on the cellular level. So this is a picture of the cell. This is the nucleus. The cell has other organelles. We're not going to draw a picture of that. But here is the cell membrane. So there are different sites. They're called insulin receptors. They're like sites, like a point of contact where insulin sends the signal, comes here to the side of the cell, and it's able to push the glucose in the cells to be used as a fuel. We know that glucose is the main fuel in virtually every cell in the body. So here is where the crux of the problem with insulin resistance lies. So imagine these receptor sites where the signal of insulin comes in into the cell membrane, that it's like a door with a lock, and insulin is the only hormone that has the key to unlock that door. So if everything is working good and the cells are sensitive to the insulin, insulin brings the glucose, the door opens, the cells get all the glucose to be utilized for energy, and the cells are super happy. But if this particular receptor sites are becoming non-responsive to the insulin signal, this is called insulin resistance. And we will discuss in another video next time what are the reasons for that. This is just the introduction of what insulin resistance means. So when you think about insulin resistance, remember, on a cellular level, that's what's happening. So when these are resistant and it's non-response to the signal, then the cells obviously are starving for fuel. They are not able to function properly, but in the meantime, the extra glucose that is not able to go into the cells because of these doors being closed, then it's continually to circulate. It's not meant to be that the glucose would non-stop circulate for so long. If somebody ingests food, insulin comes, lowers the blood glucose level, and it stays low till a couple hours later when somebody ingests more food and more glucose it's made. But in this case, this constant circulating of a higher level of blood glucose, it's causing the detrimental effects. We'll discuss more in the next video, but this is how a lot of chronic conditions happen, and that's why we need to be aware of it, what insulin resistance is and how exactly occurs. And the saddest part of all of this is that it's discovered that about 88%, that means about 1 in 3 Americans, are having insulin resistance without even being aware of it. The most common condition that comes to mind when we talk about this, it's type 2 diabetes. Also type 1 diabetes, it's connected to all of this, but type 2 diabetes, especially the metabolic syndrome, the increasing cholesterol, triglycerides, we will discuss all of that in the next videos. So when we talk about insulin resistance, this is what we can picture, and that's the mechanism. So I hope this made sense. Now, as I promised, I wanted to share this book. that actually I found very helpful, and it's by Professor Benjamin Bickman. He's PhD, a researcher. I believe he's one of the experts on insulin resistance. So I found this book to be very, very helpful to those of you who would like to further your education. It's written in a very easy to understand manner, and perhaps in some of the other videos we might refer to some of these concepts. So I hope that this was helpful to you. Thank you so much for watching. I'm looking forward to the next video. Stay well, and we'll see you the next time. Thank you so much. Have a great day. Bye bye.